Hello students, today we are going to discuss about friction. Friction is one of the important force in your motion, right? Friction is helpful in our day-to-day life. Friction will be helpful when you are walking, or friction will be helpful when you want to slow down or stop a automobile, right? So let us see what is the concept behind the friction. If you consider two cases, first is that a ball is moving on a horizontal surface. After a while, what will happen? If a ball is moving on a horizontal surface, after a while it will stop. Right? Why it will stop? It will stop because of friction. Because there is a constant opposing force to its motion which is causing it to stop. Right? Then the other one is, let's say, a block is being kept on a horizontal surface. A block of mass m is being kept on a horizontal surface and you are putting a force F on it. Now consider that a block is being placed on a horizontal surface and you are just pushing it with a smaller force. It will not move, right? Then you will increase your force, again it will not move. After a while, when you keep on increasing your force, after a while it will start sliding ahead. Now, why this is happening? Why you were initially putting a smaller force and it was not able to move, right? As per Newton's law, Newton's third law, if there is any external force, then the body must move, right? So why is that force? What is that force which is keeping it at rest? That force is friction, right? So what will happen between these two surfaces, the surface of the block and its horizontal surface? If I go on the microscopic level over here, then I'll find that at the microscopic level these two surfaces will seem to be like this. They will have the spikes, and due to this spikes there will be interlocking between these two surfaces. There will be interlocking between these two surfaces and there will be making of some electrostatic bond. These interlocking will oppose the relative motion. This will oppose the relative motion between the bodies. This will oppose the relative motion in between the bodies. That means whenever one body wants to move, one surface wants to move and the other surface is at the rest, then there will be a friction force. Friction force is a contact force. Whenever there is contact between two bodies, there will be a friction force, right? So if I go further about it, right? So why there was a motion when a ball was moving, so there was a motion, right? Again, there was a force which is deaccelerating this and bringing this ball at the rest. So first I was talking about when the body was at rest. The second case is when the body was moving but it was bring to rest, right? So there are two types of friction forces. The first type of friction force is static friction. And the second type of friction force is kinetic friction. Now, for defining any force, you need three terms. First is the point of application, second is the magnitude of the force, and the third is the direction of the force. Now, if I talk about the static friction will be applicable to a particular body whenever the body is at rest, right? Body is not moving, then static friction will be applicable. Its magnitude will vary as much as you will start increasing the force, the static friction will start increasing, and it will increase to a particular level, after which the body will start moving, right? So this will be direction. If I talk about the direction would be opposite to tendency of relative motion, and its magnitude will be variable. Up to, its magnitude will vary from 0 to a maximum value of mu s into n, right? So mu s is coefficient of static friction. This is a constant whose values will be given to you normally in your questions, right? Whose values is taken out from the experiment, right? So the value of the static friction force will be variable, and it will depend upon the force which is making the tendency in a body to move, right? As soon as you will start increasing that force, this static friction will also keep on increasing, so that it resists the motion, and it will go up to a certain value, right? And when the body is in motion, the second type of friction force will come into the picture, and that second type of friction force is called kinetic friction. Again, its direction will be opposite to the motion of the body, and its value will remain constant. The magnitude will always be equals to mu k into n. Now this mu k is called coefficient of kinetic friction. Again, it's an experimental value which will be normally given to you in the question, right? So these are the two types of motion. When the body is at static or at rest, you will have the static friction, and when the body is moving, then you will have the kinetic